Okay, I'm going to start talking about linear functions. Unfortunately, we weren't able to get really good coverage of the entire first chapter in most courses. Um, and those assignments have already been due. So if you do have a problem with some of those assignments, everybody who's done those assignments uh, in the courses that I have access to, uh, courses which have the access to the records, everybody's done those assignments, has a high score on it. So hopefully everybody understands it well. Okay, now linear functions. Here I've got, set of x, y coordinate axes. I assume everybody is familiar with this type of coordinate system. And if I draw 2 points, say here and here, let's make those points a little more prominent, then there's a single straight line that goes through these points, one and only one straight line. Now, if I have a straight edge, I can see where that straight line ought to be. I don't have it. I was kind of blocking the board when I did that. You understand what I was doing. Now, a little hard to make this work right, but there we go. I managed to hit both points. Okay. There is exactly one line that can go through these points. If the line is a little higher or a little lower, it's not going to hit both points. Okay. If it has a different slope, maybe it'll hit one point, but if the slope is a little different, it's going to miss the other one. And slope just means, well, we define it mathematically, it just means steepness basically, but we're going to make a little better definition. Now, whatever the coordinates of this point are, whatever the coordinates of this point are, we can calculate the slope easily if we know the coordinates. So let's just say this point is, oh, what do you think? Let's say this is -3, 11. So that means this will be the line x equals -3. Vertical line, the horizontal line would be y equals 11. Then a vertical line through the second point. I kind of missed it, but you understand what I'm doing. If this is 3, that's about what? 3, 6, 9, 12. Really kind of came out 11, but I don't want to have two 11s in here. I want to have different coordinates. And what would this be? Well, that looks kind of close to -3, but we'll say this is y equals -4, just so we don't have a couple of -3s in there. All right. So now we know that this picture represents the straight line that goes through the point -311 and the point, haven't labeled it, but x is 12. I don't want to label it there. Yeah, okay. 12, -4. Okay. Now the slope. Said I was going to define the slopes. That's exactly what I'm going to do. If I go from this point to this point, I'm going to draw a little arrow. I'm going from the left to the right, leftmost to the rightmost point. Should be left more, right more. But everybody says leftmost, rightmost, I'll live with it. Okay, so if we go from this point to this point in this direction, that's one path that goes from here to here. Can I draw another path on these vertical and horizontal dotted lines that goes from here to here? And the answer is, yeah, there are two ways to do it. I could go from here down to here and then over to here, and that keeps me on the lines, the dotted lines. Or I could go from here to here and from here down to here. Okay, it's really arbitrary choice. I'm going to choose to do the upper path along the line y equals 11, then down along the line x equals 12. So now my path is going to go from here to here. And I put an arrow on that because otherwise it's easy to make a mistake with the signs. And I draw an arrow from here down to here. Okay, well, this arrow represents what we call the run. And this arrow represents what we call the rise. Now we have a negative rise because the line is going down. We're going to have a negative slope. If the line was going up, we'd have a positive rise, but this is the rise from this point to this point. It's how far we move in the vertical direction. And it's positive for moving up. It's negative for moving down. Now, we can get the rise easily by subtracting the y-coordinate here from the y-coordinate here. That is, we subtract where we end up. I'm not saying that right. We subtract where we start from where we end up. So we do this minus this. The x-coordinate down, or the y-coordinate down here is -4. And the y-coordinate up here is 11. That gives us -15. Okay, the run. Okay, that makes sense. We're going from y equals 11 down to y equals 4. How far do we have to go? Well, from 11 down to the x-axis, where y is 0, from 11 down to 0 is -11. And then we still got to go -4 more, giving us -15. But again, always we subtract where we start from where we end. Okay, over here on the run, we subtract where we start from where we end. Well, the run is in the x direction, so we start at x equals -3 and we end at x equals 12. Subtracting where we start from where we end, we get run equals 12 minus -3, which equals, I'll write it out, 12 plus 3 equals 15. So we have a rise of -15 and a run of 15. The slope equals rise divided by run, which equals rise is -15, the run is 15, and that equals -1. Now, when I do this, and this is not a convention in other courses, I put a box around this result so I can easily spot the slope. So one way or another, you can do this. If you're in my class, you have to do this. In other classes, you don't. Now, you should be able to write out all of this. If you do, you'll understand slope. If you do this on several problems. Now, the text gives you a formula. And the formula M is the letter most often used for slope by almost all authors. M is the slope. And in some cases, it could be A, and we'll see that in a minute. The slope is M, and that's rise divided by run. How do we get the rise? Well, if this point is x1, y1, and this point is x2, y2, so let's just generalize this. This is x1, y1, and now we'll represent this point as x2, y2. And I'll kind of circle those with a bright color. In terms of x1, y1, and x2, y2, we got the slope equals what? Well, it's rise divided by run. The rise is this minus this, which is y2 minus y1. And the run is this minus this and be the x coordinate here minus the x coordinate here, which is going to be x2 minus x1. Fairly easy formula to remember, but I strongly advocate that you understand this picture and understand what this formula is telling you rather than using the force mindlessly, which gives you no real feel for what the slope is telling you. Okay? So there's a formula. M is the slope. And I'll point out that the rise is the numerator and the run is the denominator. Okay, well, one way or another, if you're given 2 points now, and you know their coordinates, whether numerically or symbolically, you can write out their slope. Okay? Now, let's say I have another situation here where I've got 2 points. And let's say I've got a point here. I'm sorry, I'm not going to have 2 points. I have a point here. I'm going to do it with numbers. Let's say the point is I'll make it -4, -5. I don't want the same number twice. Not in the first example. Okay, so we have the point -4, -5, and we're given that the slope is by 1/2. Now, slope of 1/2 and the given point, there's only one line through this point that has a slope of 1/2, which might be about like this. What does the slope of 1/2 mean? It means the run is twice as big as the rise. Okay. So we could do a run here. And any old run will work. Okay. If I do a run and then I do a rise, it's half as big as the run. And I think I want to make my run a little longer because my rise is going to come up pretty close to the x-axis. Okay, we've got this big long run. And then we've got a rise that's half as big. Assuming we have equal scales here, that means the rise would bring you up to about this point. And then the rise is half of the run. It's a bad look on athletics. Oh, okay. That gives you another point. And now I can draw the line joining these 2 points. Now I don't have an equation. This is the line joining the 2 points that I get. The point that I'm given and the point I get when I do a run and a rise that are in the proportion of 2 to 1. Okay, well, if I want the coordinates of this point, I can specify the run. Okay, the run in this case, well, if this is 4 units here, and if this point's -4, -5, then this line is certainly the line x equals -4. And this line here that I'm not going to label is y equals -5. If I moved this distance, okay, well, how far is that? If this is 4, and that's 4 more and 4 more, I'm going to say this is 10. Now you can use any run that you want. But once you know what the run is, the slope is going to tell you what the rise is. The rise is going to be half of the run in this case, So the rise is half of 10, which equals 5. Okay. Now, if I know that the run is 10 and the rise is 5, and I'm starting at the point -4, -5, then what are the coordinates of this point? Well, if I start at -4 and go 10 units, this point has to be at x equals -4 plus 10. And the second point has to be 5 units higher. And boy, I messed that up, didn't I? Because it tells me that this point here really ought to be on the x-axis, which is what I was trying to avoid. But we're just going to live with it. Okay, we're going to say the rise goes from y equals -5 at this point plus 5, which equals 14, 0. Well, in this case, I'm going to have to redraw my line. Okay, well, I'm not actually going to redraw it, but I'll just say the correct line then would actually be here. So there would be my rise. There would be my run. And there's my line. And I'm going to say this line, you're just going to kind of neatly cross out in this part of the rise arrow. Okay, now let's do all this with formulas. Okay, we have the slope formula, y2 minus y1 divided by x2 minus x1. If I have the point -4, -5, and if I have a slope of 1/2, let's just take a point xy on the line. Then what's the run? From -4 up to x, the run is x minus 4, x minus -4. And the rise is y minus -5. Rise over run is then y minus -5, but of course that's y plus 5. So I'm going to write down y plus 5. Over x minus -4, I'm going to write down x plus 4. The other thing we know about the slope is that it's 1/2. So now we have an equation, y plus 5 over x plus 4 equals 1/2, but we can solve for x. If we multiply both sides of that equation by x plus 4, we're going to get y plus 5 equals 1/2 of x plus 4. We can solve for y. Here we get y equals 1/2 x plus minus 3. Now, I did a little bit of arithmetic there, a little bit of algebra. I get 1/2 x, I get 1/2 times 4, which is 2 on the right side. I've got to add -5 because I got y plus 5 equals on the left side. If I want to solve for y, I'm going to have to add -5 to both sides. And 2 and -5 adds up to -3. Okay. What's the form of this equation? Let's do the same thing, except my first point is going to be x1, y1. My second point is going to be xy. And the slope, instead of 1/2, we'll call the slope m. Then, moving horizontally from x1 to x, my run is x minus x1. My rise is y minus y1. So that slope equals rise divided by run, which equals y minus y1 over x minus x1 equals the slope. If y minus y1 over x minus x1 equals slope, we multiply both sides by the denominator, x minus x1, and we'll write that x minus x1 over 1 since we're multiplying fractions. And we got y minus y1 over x minus x1. So our equation, y minus y1 over x minus x1 equals m, multiplying both sides by x minus x1. We get x minus x1 over 1 multiplied by y minus y1 over x minus x1 on the left-hand side. And we can see that x minus x1 is going to be a factor of the denominator and a factor of the numerator. So it divides out. We don't need the 1. We get y minus y1 equals x minus x1 times m. We don't have to do x minus x1 over 1 because m is not given. In this case, as a fraction. It's just the letter m. So we have x minus x1 multiplied by m. And I'm going to write that as m times x minus x1. Now, here's a formula. Formula means something, and I recommend that you understand what it means because you'll be able to use it better. You'll understand more about straight lines. But whether that you do or not, here's a formula. Okay? So what do we have? We have two formulas. M equals y2 minus y1 over x2 minus x1, which works if we've got the coordinates of the 2 points. And then we have the equation y minus y1 equals m times x minus x1. Also true for any straight line. Here, in this formula, if we know x1 and y1 and m, then the only variables left in the equation are y and x, and we have y as a function of x. We'd have to add y1 to both sides, but that's easy enough to do. Okay. If we have 2 points, so the formula y minus y1 equals m times the quantity x minus x1 we use if we know the point and the slope. And we don't need the formula m equals y2 minus y1 over x2 minus x1. However, if we have 2 points, writing use if you know 2 points with an arrow at m equals y minus y1 over x minus x1, you use this formula to find the slope, and then you can use this formula to find the equation of the line. Okay, well, that's a basic idea of the equation of a straight line. Do a quick example. Given slope 3/7, in point 5, -12, we get slope m equals, oh, sorry, we don't get slope. We get the equation. We get y minus y1 equals m times x minus x1. The points 5, -12, x1 is 5, y1 is -12. So y minus y1 is y1 minus -12. So instead of writing y minus y1, we write y minus -12 equals m times x minus x1. M is the slope, so we're going to write on the right-hand side, we're going to write the slope m first. That's 3/7, and that's multiplied by x minus x1. X1 is the coordinate of the point we're given. X coordinate of the point we're given, we have x minus 5. This becomes y plus 12 equals 3/7 of x minus 5. And now we've got to do a little bit of work with fractions. There are a couple of ways to do this. And I don't want to deal with addition or subtraction of fractions. So I'm going to multiply both sides of the equation by 7. So I get 7 times the quantity y plus 12 on the left-hand side. And 7, which I'll write as 7 over 1 because of the fraction, multiply. 7 times 3/7 times x minus 5. But I write that as 7 over 1 times 3/7 times x minus 5. Multiplying 7 times the quantity y plus 12, 7 times y gives us 7y. 7 times 12 gives us 84. Multiplying 7 over 1 by 3 over 7 gives us 3. And we still have our x minus 5. So the right-hand side reads 3 times the quantity x minus 5. Left-hand side reads 7y plus 84. I'm running out of room. I didn't intend to do this many steps. But we subtract 84 from both sides. Okay, I'm getting messed up. Make this out a little better. Okay, left-hand side becomes 7y plus 84 minus 84. Right-hand side becomes 3 times the quantity x minus 5, the quantity, minus 84. And we end up with 7y equals 3 times the quantity x minus 5 minus 84. We can use the distributive law on the 3 times the quantity x minus 5. And we end up with, on the left-hand side, we still have 7y plus 84. On the right-hand side, we're going to have, well, 3 multiplies the x in the x minus 5, and 3 multiplies the minus 5, giving us 3x minus 15. Then we have minus 84. And I wrote the left-hand side down incorrectly. I wrote 7y plus 84 because that's what my eye saw. My brain wasn't functioning. But the left-hand side, of course, when we do 7y plus 84 minus 84, that leaves us with only the 7y. So we have 7y equals 3x minus 15 minus 84. So 7y equals 3x minus 99. Now we want to solve for y, so we divide both sides by 7. Get 7y over 7 equals the entire 3x minus 99 over 7. So the left-hand side just becomes y. 7 divides 3x, giving us 3/7 x. And 7 divides the minus 99, we get minus 99 over 7. So that's what we get if we use what's called the point slope form. Y minus y1 equals m times the quantity x minus x1. And sorry if that solution had to wrap around the board just a little bit, but there it is. I'm not going to do one if we've got 2 points. Okay, we've already done one of those, but not necessarily using the formula. Remember, previously in our first example, we got a slope of -1. So m would be -1. And x1, y1 could be either of the 2 points that were given. So the only difference between what we get if we're given a point and a slope and what we're given if we got 2 points is if we're given 2 points, we have to calculate the slope. And then we have to pick one of the points to use for x1, y1. Doesn't matter which one. And it's always a good exercise to do it both ways. Pick one of the points and see what the formula comes out, and then pick the other point and see what the formula comes out. It should come out exactly the same when you end up solving for y. You should get exactly the same expression. Now, there's one more thing you would do is maybe check and see if this really works. Yeah. We have the point 5, -12. We have the equation y equals 3/7 x minus 99 over 7. I'm just going to say what we do. We plug in 5 for x. We have 3/7 x. 3/7 times 5 is 84/7. 15/7. Okay. So the right-hand side becomes 15/7 minus 99/7. Well, 15 minus 99 is -84. And -84 divided by 7 is -12. So we get y equals -12. So if you plug these numbers in and do your arithmetic correctly, you will confirm that if x equals 5, then y really should equal -12. And that pretty well completely confirms your solution. I always strongly advocate the check. Okay. Now there are other characteristics the straight line has. And maybe I'll use, no, I don't want to use that line. Okay. Let's consider the equation. y equals 2x minus 18. Let's see what we can determine about the graph of this equation. Okay. Now, let's draw a y-axis, and I'm going to draw an x-axis. Here's the x-axis, here's the y-axis. The x-axis is the line y equals 0. The y-axis is the line for x equals 0. Whatever your straight line, it's going to intersect the x and the y-axis, unless the line is completely horizontal, like y equals 5 would be a horizontal line. You would never intersect the x-axis. It would be 5 units above the x-axis forever. Or if you have a vertical line, x equals negative 12, okay? That'd be a line maybe over here to the left of the origin, left of the y-axis. And it would go through the x-axis, but it would never go through the y-axis, okay? So a horizontal line will go through the y-axis, but it won't go through the x-axis. A vertical line will go through the x-axis. It won't go through the y-axis. Otherwise, the line goes through both the x and the y-axis. And we call those points the x-intercept. I don't want to clutter up my board here. So the x-intercept happens when y equals 0. If y equals 0, then your equation y equals 2x minus 18 becomes 0 equals 2x minus 18. Solving that for x, we get x equals what? Well, you add 18 to both sides, you get 2x equals 18. You got 0 equals 2x minus 18. Add 18 to the right-hand side, the minus 18, and the 18 will give you 0. Add 18 to the left side, you're adding 18 to 0. So you're going to get x equals 18 over 2. Now there's a step between that. You add the 18 to both sides, and then you've got 2x equals 18. And you're going to divide both sides by 2. You're going to get x equals 18 over 2 equals 9. Now that's what happens if y equals 0. Well, y equals 0 on the x-axis. So x is going to equal 9 when y equals 0. That gives us the point 9, 0. And we go ahead and draw ourselves a vertical line and label it x equals 9. And then we put a point at 9, 0. And this is the x-intercept. Which occurs at the point 9, 0. That is a point on the line. Now, that's where the line crosses the x-axis. Now, it also crosses the y-axis because the slope isn't 0. We say that the y-intercept occurs when x equals 0. If x equals 0, then for the line y equals 2x minus 18, we get y equals 2 times 0 minus 18. Well, 2 times 0 is easy, that's 0. This just gives us y equals negative 18. So the y-intercept is often the easy one. The x-intercept, you've got to do a little bit of work to solve an equation. Okay, so we have anyhow that y equals negative 18. So when x equals 0, y equals negative 18. We can then say it's a point 0, negative 18, which occurs when x equals 0 and y equals negative 18. It's a point on the graph and it's on the y-axis. Now we can sketch our line through the 2 points and label the line y equals 2x minus 18, which we write somewhere near the line so that we know what we've done. I'll pause the video just for a second. Okay, I wanted to double check. Think about the time and how much time I've got left. Let's suppose now we have a second straight line. Okay. Got a slope of negative 1/2 and the point on the line is, let's say, negative 6, 12. Now we can attempt to sketch that line. Okay. If this is 9 units, 2/3 of that would be 6 units. That means the line x equals negative 6 would be a bit to the left of the x-axis. And I've sketched that line. 12 is the y-coordinate. Well, we see how far 18 is below 0. From the origin to 0, negative 18 is 18 units. We go about 2/3 of that distance. But since this is positive, 2/3 of 18 is 12. 12 being a positive number, it's going to be 2/3 of the distance from the x-axis down to the y-intercept, 0, negative 18. It's going to be above the x-axis, so I'm plotting a point that attempts to indicate the point negative 6, 12 on the same graph as I have for y equals 2x minus 18. So that's the line, horizontal line y equals 12. And the slope is negative 1/2. Well, that, for example, means that if I move, let's say, 6 units from x equals negative 6 to x equals 0, so we can see on the graph that's a distance from the x equals negative 6 line to the y-axis. Then we're going to have to move negative 1/2 because the slope is negative 1/2, negative 1/2 of that distance in the y direction. Now, negative 1/2 times 6 is negative 3, means that we have to move over 6 units and then down 3 units. So I'm sketching a point on the y-axis that's something like 3 units below the y equals 12 line. Of course, that would be the y equals 9 line. Then I'm going to draw a straight line through these points and estimate where it intersects with the line that I drew for the previous function, y equals 2x minus 18. Now, my scale isn't very good. My 3 is a little too big. And the point should really be somewhat higher and further to the right where the two lines cross. But according to my picture here, a plausible estimate, here's x equals 9. The vertical line through the point where the two lines cross is maybe x equals 11. And the y coordinate, which is going to be a little bit low, I think. Okay, if this is 18, what's this? I'm going to say it's maybe about 4. Okay, crossing point is at 11,4. Now, if I use the slope-intercept form of the straight line, the equation of the line, as you I'll color the chalk there, we make this line blue. Okay, if you can see that, that's fine. But the equation of the line if you use the slope-intercept formula, y minus y1 equals m times x minus x1, you pretty quickly get an equation for this line. And that's going to be y minus 12 equals negative 1/2 times the quantity x minus negative 6, using y1, x1, y1 as negative 6/12 and m as negative 1/2. If we solve this equation for y, we get y equals negative 1/2 x plus 15. And that works. Okay, that gives us a given point, and it has to have the right slope. If I want to calculate the point of intersection, then that point first, and I've got to pause just a second because it's time for me to send out a link to my next class, which starts in a few minutes. Okay, again, you get the point of intersection. Sorry, I had to send a Zoom link for my next class, which starts right on top of this one. Point of intersection is going to be on the lines y equals 2x minus 18. That's the equation of the first line. And y equals negative 1/2 x plus 15. So at the point of intersection, Doc just doesn't want to cooperate here. So if y equals 2x minus 18 and y equals negative 1/2 x plus 15, then 2x minus 18 has to equal negative 1/2 x plus 15. That's an equation we can easily solve for x. I'm out of time. I'm not going to be able to do that. But if you do solve for x, you're going to add the and say you add the 1/2 x to both sides, you're going to get 5/2 x. Add 18 to both sides, you're going to get 33. So you're going to get x equals 2/5 of 33. That might be hard to read. I'm writing in a difficult position there, which is 66/5, which is by darn 11. Look at my estimate. That's just dumb luck, okay? But I estimated x equals 11. I got it. And I didn't work this out previously. I just got lucky. If you plug x equals 11 into the first equation, you get y equals 22 minus 18, which is 4. Now, again, this is an inaccurate, and I said before, I thought that the point of intersection would be out here a little further. X would be a little more than what I estimated, and y would be a little more. Okay, so somehow I just lucked out and got the right numbers. Again, if you plug 11 into either of these equations, something doesn't work. Maybe I did that in my head wrong. Oh, okay, it's not 11. I mean, it's 11 and a fifth. If you plug into here, you get 4 2/5. So I didn't hit it exactly. Should be 11 and a fifth, 4 2/5. If I've done that correctly, but I do have to stop now. So hopefully that gets you a little bit of a head start on the upcoming material on lines.